Hello everyone, and thank you for tuning in this video today, where we're going to start talking about solving multivariable systems of equations with a new method called Gaussian elimination. So this is really like an introduction to what a matrix is, even though we haven't really got into it yet, and then how to solve it into what's called row echelon form. So before we do this, I would suggest that you pause this video, and there are two problems on our first slide. If you want to go ahead and try those two just for a little review, we go ahead and do that, and then when you're ready, you can come back and check your answers. And here are the answers to the warm-up problems for today. So what we're trying to do today is basically solve this problem right here. We're using a different method, using something called a matrix and Gaussian elimination. All right, we're just going to go through one example, that's it, and then I'll have you try a couple on your own, and that will really be it for what we're going to do today. So it says solve using Gaussian elimination, write the equation in row echelon form. Okay, so first of all, we're going to set up this thing called a matrix. A matrix has these big brackets here, and basically all we're going to do is take the constants, no variables. So it's going to be 1, -2, 3, and 9. -1, 3, 0, and -4, 2, -5, 5, and 17. Let me fix my -4. It looks terrible there. Let me move my -2 over a little bit. All right, and then we like to separate the left side from the right side using this bar here, vertical bar. All right, that's called a matrix, okay? There are 3 rows in that matrix and 4 columns. So 3 rows and 4 columns in that matrix. And what we want to do is use Gaussian elimination to write it in row echelon form. What does row echelon form mean? It means that if we were to put a diagonal right here, we would want everything below that diagonal to become 0. Now, there's also something called reduced row echelon form, where we want everything but the diagonal to be 0. But for right now, just having these 3 be 0 and converting these to all 1s is where we want to start. Okay? So we're going to do basically what we did here, but just in a little bit different format to start. All right. So I'm going to start here by copying down my matrix and copying down the first row here. All right, now for the second row, we want to get rid of this number. So what we're going to do is we're going to take the first 2 and eliminate x. Well, luckily, that's already done for us. So it's going to be row 1 plus row 2. X plus -x is 0. -2y plus 3y is 1y. 3z plus 0z is 3z, and then 9 plus -4 is 5. Okay? Now we're going to do the same thing for the third row. We're going to try to eliminate an x again so we can get another 0 right here. All right? So now there's 2 different ways you can do this. We can use these 2, or we can use these 2. It doesn't matter which one you want. I'm going to use the second one since it's already negative there, so I'm going to do 2 row 2s plus row 3. So two of these plus 1 of these. So -2x plus 2x is 0. 6y minus 5y is 1y. 0z plus 5z is 5. And then -8 plus 17 is 9. All right, so now we've gotten almost where we need to be. Our next step is now we want to change this to a 0. Remember, we want everything below this to be a 0, right? So I'm going to cheat a little bit here, and I'm going to copy this whole matrix down. And I'm just going to go ahead and get rid of this last row here. So what I'm going to do is we're going to take these 2 bottom rows, and we got to figure a way to get rid of this. All right, so now if we just take this row and subtract this row, that'll give us a 0 there. So 0 minus 0 is still 0. 1 minus, well, let's write this down here. Row 2 minus row 3. 1 minus 1 is 0. 3 minus 5 is negative 2. 5 minus 9 is negative 4. All right, and then our next step is we want all of these to be 1s. So, I got really good news here. 2 of those rows are already 1. We just need this to be a 1. So we're going to do negative 1/2 row 3. And that's going to be 1 and 2. All right, now we can do our back substitution. So this means z is 2. 1z equals 2. So 1z equals 2. There's one answer. In the next row, we can do 1y plus 3z equals 5. So y plus 6 equals 5. Y equals negative 1. And then the top row, 1x minus 2y plus 3z equals 9. So x plus 2 plus 6 equals 9. X equals 1. So our final answer is 1, negative 1, 2. Okay, from here, there are a couple practice problems that I'd like you to try. So go ahead and try those 2. When you finish the 2 problems that you can try, you can stop there, come back and check the video, and hopefully you will have done them correctly. Here are the answers for the 4th one. Feel free to pause it here if you need to look at it longer. And the 5th one. And that will do it for our video today on Gaussian elimination in row echelon form. Thanks as always for checking out the video, and we'll see you again soon.